Hi, good morning, everyone. Am I audible? If I'm audible, kindly write yes in the chat box. Great, great. Yes, so let's begin our presentation. So my name is Rishabh. I'm working as a regional manager in Midas IT, and I'm working for entire North and East region in Midas, India. So I am thrilled to welcome you to today's expert webinar on hydropower structures, where we have the privilege of hosting Mr. Chetan Agrawal, a renowned authority in hydropower engineering. Mr. Agarwal serves as the technical principal for hydropower at Mott MacDonald, bringing with him a wealth of knowledge and innovative experience in sustainable energy solutions. Now, with a decade of expertise and a track record in pioneering hydropower projects, Mr. Agarwal's insights have been invaluable in shaping resilient and efficient hydropower infrastructure globally. So today we are very fortunate enough to have him guide us through some of the most pressing topics and emerging trends in the industry. So thank you so much, Mr. Chetan Agrawal, for joining us, and to all our participants for being here. Now let's have a quick look at today's agenda before we dive in. So I'll just wait for one more minute and then we'll start. So this is going to be the schedule of our webinar series. So today we'll be focusing more upon the terrain modeling and overflow dam modeling, proceeded by the excavation modeling for overflow block, modeling of right NOF block and a part of earthen dam. Then we will further dig deeper into the modeling of left NOF block part and a part of earthen dam. Then we will model the gallery, concrete zoning, lift, stairwell, and converting MADAS geometry file into CAD file. So in these four topics, we are going to cover the detailed modeling of each and every aspect of a dam. Will definitely save a lot of time in our work proceeded ahead after this. Now, the topic 5, 6, 7, and 8 is the topic which we will focus on the analysis part of dam of NMF block. So as you can see, session 5 is the deepest NF block model update, and we'll mesh it and then we will apply some of the load over it. Then in the session 6, we will do pseudo-static stability analysis of NF block and model setup for dynamic time history analysis. Then we will proceed ahead for dynamic analysis of TB and going through the relevant clauses of USAC EM 6051 for the analysis of gravity dam. And last but not the least, we will proceed ahead with nonlinear static stress analysis, crack propagation, linear time history analysis, and the result interpretation. So as you can see, in these 8 sessions, we are trying to cover the dam part right from the basic, like how to plan, how to model, and how to do the analysis of a dam structure. Now let us not wait further and straight away dive into the presentation.
My name is Chetan Agarwal and I'm a civil structural engineer. I'm in hydropower industry from last 20 years now, and I'll be delivering few webinars on modeling and analyzing hydropower components in Midas FENX and other Midas software. Without wasting more time on introductions, I'll start webinar on dam modeling. So this is a Midas window and I'll start from the scratch. See, we have contours of a region and we have dam axis with us. This is a dam axis. Okay, we have identified this dam axis and we have a contours of this region and we have rock line also for this. From here, we'll start modeling our dam. Okay, and see in Midas FENX, you have this terrain geometry maker feature also. You can utilize this also. But I'll be using other technique for developing these topographic surface in Midas window, so that I have a specified region what I want. You can use that terrain geometry maker feature also, but somehow I like this method, so I'll be using this e-text command. Get for that. So once you practice this, you will get to know what are all these commands. So this is dam axis. Probably I can start my contours from here and So contours, if these contours are polylines, we have to extrude them first to make them lines. I have already extruded them. And this I need properties, geometric properties of these lines. So I don't need 3D visualization data, drawing data, or general data. And that too only the start coordinates of each line. So it will take some time. The text command is processed. It may take some time, say 4 or 5 minutes. I think you won't mind spending 4 or 5 minutes in that. So this contours file that has been created here. So so these are the contours. Well, yeah, this Excel file. See, for this dam already hydraulics has been, evaluated. The salient levels, water levels, and dam top has been at water level, and we have done some initial hydraulic calculations for that. Anyways, we'll be coming back to it. But now we have these contours file with us. So as contour spot points. So these points I can take to with us. Again, it takes some time because the number of spot points are more than 35,000. The spot points have been created like this. Delete these extra points. And then create a surface from these points. Make face point and select these points. These are about 35,000 points. Click OK. Again, it will take some time to generate the surface. So this surface is created here. So it's like this. I don't need these spot points anymore. So what I'll do, I'll delete these spot points. See, it may take some time, say 10 minutes, 10-15 minutes for all this exercise. Extracting data from AutoCAD and creating this surface, but I don't think you would mind spending 10-15 minutes on this exercise. So select all these points. Again, it will take some time for selecting 35,000 points. So deleting these points will also take some time, some 4-5 minutes. It may take 4-5 minutes depending on your RAM and processor speed. Okay, so after deleting this, we will be left with this surface only. It will make our file lighter. It may happen that deleting these number of points, your software may crash 35-36,000. In that case, try deleting 5,000 points at a time. First delete 5,000 points, 5-6,000 points, then again 5-6,000 points. So delete those points in parts instead of deleting entire all the points together. It all depends on your uh, processor, RAM, and memory of your computer. Anyways, let's move forward. So we have this topographic surface with us. Now we'll plot dam axis. So we have this dam axis. What I'll do, I'll make this layer as the current layer. Okay, and dam axis layer. Okay, and okay, so this is my dam axis. Use this ID command from AutoCAD. This one, repeat this one, this one. These are the IDs. Copy this, paste it somewhere in Excel. Here. Okay. You may have better technique to extract this data in Excel. Why? Oh, sorry. Text to column, next, space, and finish. Okay. Okay, so these are the coordinates. I can plot these points. Midas. This is the one. I can create a 3D polyline here. Okay, now using, so this is X, just 11165.19, this length. Okay, and this length is 824, so 1200 meter. I'll create one box here. In next direction, 1200, width say 100 meters, 150 meters, some arbitrary number, so that it exceeds the base width of dam. So it can be arbitrarily large number, 150 at the initial point, and height is 293 was the top. Keep 293. Okay, and let's place it here. Okay, now translate it. Okay, this dam axis has a kink here. So what I'll do, I'll have to find out the angle. What is this angle? 3.969490. We should cut this at this plane first. For that, change the work plane to this axis. Let's say 10. Change Y some axis. Okay, and divide command. Probably we can mirror it. That would be better option. Now we can rotate this. How much was that? 3.969490. Was it correct? 69490. Yes. Let me minus. Okay. This is fine. Then create a 3D line here. Hide these. Intersect these two lines. Okay. Change work plane to this plane. So we have this and now you can see, so the dam axis is here. Okay, so it seems to be okay. Now we have to plot what rock line. Okay, for that what I will do, will switch on the rock line layer here. Okay, and text layer also. Okay, and for this rock line, can again use that text command. Oh, I have to explode it first. So actually, y is on this side. Okay, and this level should be, these text should be 1. It's 8.5. 300 minus 8.5 is 291.5. Okay, this should be Z. Its value should be 291.5. Least X. So first, let's sort this data by x-axis. Okay, so this should be 291.5. So the difference between these two are 5037. Let's remove these 2 points first. .3D polyline. Okay. So it looks to be good. I don't need these points anymore. Let's plot this rock line here. For that, I'll change my work plane again. Why is it 10? Whatever. See, and change this. Okay. Divide this. And then create a perpendicular line here. Okay. Delete this. Use this command translate sweep. We clocked it. Okay. So this is the rock line. Okay. So let's see the hydraulic calculations once again. Okay. So total 27 bays have been considered. Overflow bays have been considered with gate width of 8.35 meters. Let's keep 3 extra bays for it. Say 30 bays multiplied by 8.35 meter is the width, and with each base, so it's going to be a quite high dam because foundation is deepest foundation will be at about 214 or 15 level, so it will be about 70-80 meter high. So with for every overflow block will provide one expansion gap, one contraction joint. So for every bay we'll have two piers. Let's say thickness of each pier is 3.5 meter, which should be adequate for providing gates, radial gates, and the stop locks. And 3.5 meter width plus into two both sides. Okay, and number of bays are total 30. 30 multiplied by 8.35 for 60.5. Okay, and each bay will be 8.35 plus 3.5 into 2, 15.35. Okay, so where should I keep Mm, I can start it from somewhere here. Let's see. Okay, we'll change if it doesn't work. So somewhere here, 13085.7, 13085 I'll keep. I'll start my overflow section at 13085 towards this side. Okay, so 13085. So for that, I'll change my work plane to, okay, let me keep it here. V, Y, change Y, and then change Z. Okay, and create a face here. Okay, and how much was the total length? 460.5. That is 15.35. Okay, translate X in this direction. Copy minus 460.5. Okay, now I can divide these solids. This is fine. No need this one by these surfaces. So my overflow block will be in this region, and I should boolean these. Okay, and the deepest point here is somewhere here. It is about 215.74. So let's say I'll keep my founding level at say 213 level. Okay, so 213 level I'll keep. Okay, so this is at 00. Extract a face here. So this will be my overflow block, and this part will be NI block. Translate this face in vertical direction. This is 00, global 00 direction. I have to select the vertical direction, Z direction. Okay, and how much was that? 213. Okay, so I'll keep the foundation of the OA block here. Now divide this. This. Okay. Now this will be the foundation of overflow block. So before moving forward, uh, let us model overflow block first, then we'll move forward. So this upstream phase, this is our dam axis. Okay, upstream is towards this side, and then let's go to the hydraulic computations again. So we have these crest profile. Okay, upstream crest profile, downstream crest profile, and this breast wall profile also. So it's a high, the piers will be quite high here, so it's always better to have a radial gate with the breast wall if the pier height is say more than 10, 12 meters, 15 meters. Okay, so and then we have a bucket. So uh, so you will get these computations from the hydraulic engineer. I have created this sheet. I mean, these coordinates are linked with whatever uh, equation of these curves we are getting from hydraulic calculations. So, but I need the first pier point here. So my first pier will start here. So for that, I'll model 2 points here to get the coordinates. Okay. Uh, this, I don't know why it has been created. Okay, now we have 2 points. Okay, select this point, go to properties. So you will get the coordinates here. Copy it and paste it in your Excel. Okay, and better 13085.7. Okay, and this is minus 3981.93. Okay, and the second point, so you can create your own these sort of programs. So it is not a very, I mean, it's not a rocket science. It's just linking your model values with the value you obtained from the hydraulic calculations. This one. Okay, so this is same. Okay, and this is minus 3831.93, and it doesn't matter. Okay, this is 293. Okay, now this is the downstream profile, downstream spillway profile. I'll copy this first, the downstream spillway profile, copy, and I'll plot the points here. And for that, I'll delete these points. I don't need anymore. Let's plot these points here. Okay, it's in this direction. I'll rotate it and I'll take it here. Okay, later, then next is upstream coordinates, copy. So this is the upstream coordinates. Then, so for bucket, these are the tangent coordinates for bucket. So where the hydraulic engineer has fixed its bucket, so I won't be needing these extra points below this. So my flip bucket will be something like this. Okay, then I'll have breast wall profile. Okay, it's like this. So won't be requiring this one, and these ones. Okay, and now I can rotate this was the first point, no, by 90 degrees. Rotate these points by 90 degrees. Okay, and I'll keep my crest at dam axis. move it 2 points. Okay, so this is the crest level. Now I can probably switch off this, and firstly I'll create my spillway profile using this 3D polyline. This one. Okay, done for this. Okay, okay, and we have to take the crest level to 236. That was the crest level identified in, I mean fixed it in this hydraulic calculations. Crest level of this 236. So at the moment it is at 293. So 293 minus 236, 57 meters. I have to take it down. So probably I don't need these points anymore. Remove the points. Translate. Is 57. Okay, and switch on this last solid which we have created. So better to align the work plane along this. So line my work plane along this. Okay, so this is the for flip bucket, and instead I'll align. Okay, let's keep it. Now we have to create the flip bucket. Flip bucket radius is 45 meters, and this is the bottom elevation of flip bucket. So, and these will be the tangent points, this one and this one. I think this won't work. So what I'll do, I'll create a 2D line here. Okay, and then coincide this line, this tangent line, this line, sorry, and this line. Okay, okay, so it's like this. Now it should work. So I'll have this, I'll create a 2D circle here with this, and the radius is 40. Select this one and this one. Okay. And then so this flip bucket, that is 3.5 meter. What is the lip? elevation of flip bucket 45 meters, 40 meters I had kept. It should be 45 meters. Okay, let's keep it 40 meters as such. It is not correct, so I'll change it to 45 meters. 45. This one and this one. Okay. Then this is the lip, elevation of lip level. This is at 226.37. I have, it is linked with the coordinates. So the bottom lip level is at 234. So this should be 226.37. Okay. So this level, let's see this level. Check it out here. So this is 226.37. Okay. And to take it to 234. This level was 213. So 234 minus 213 is how much? Okay. 21 meters. Okay. Translate it here and can now better. I should it off for creating this. I don't need this. I don't need this. Oh, this I will need. Okay. Since it is not touching here, so I have to do some jugglery. Actually, this profile should be like this. Okay. The tangent point to this is somewhere here, not here. Anyways, I'll first and trim this. Trim this one. This one. Okay. Don't need this. Let's keep it. This I don't need. No, I don't need this also. So now I can probably have to do some approximate translation as the tangent points are not following on this curve. Ideally should. Let's see where it is following. Say 1. It seems to be okay. Should be somewhere here. Okay, let me move it slightly more closer to the curve. 1.1. It looks better. Okay, it's probably 0.5. Say 0.7. Okay, it looks better. Let's keep it here. Okay. can this one. Hmm, don't need this anymore. Don't need this anymore. So the profile will look something like this. Okay, it will go up to here, and this is 3.5 meter thickness I have on this side. Create this. Okay, so this will be my spillway profile as per the hydraulic calculations. Now let's put on that overflow blocks again, that solid block. Okay, just have to move this profile a bit because this should lie exactly at the dam axis. So translate all these lines except this one to here. Okay, okay, and can create a perpendicular line from here. Okay, uh, you will find that normally we will require about 10.5 meters towards the upstream side from the dam axis for sufficient space for stop lock groove, for operating those spots stop lock groove, and for that pier profile. So what I will do, I'll extrude this further to this direction to 10.5 meters. Okay, so my spear will extend up to here, and this will go beyond this. Okay, let's say upstream slope of this dam is 0.2 horizontal to 1 vertical. For that, I'll create one line here. So what is this? 1.21 degrees, one vertical, oh sorry, 810. $78.69. Okay, rotate this last line about the axis perpendicular to this by how much? By this degrees. It's going like this, so minus this much. Okay, and then I can translate this Okay, so this is our what do you call the foundation level. So again, I'll create the 3D line here and trim it, translate this last line 2 points. Say about 35 meters. Okay, to here only. Okay, dam top is here. We'll extrude it further by another say 15 meters so that it is covered with this. Okay, no issues. Okay, this will be the line for the pier. My pier will end here. Okay, let's boolean these first, boolean fuse these first. Okay, actually I'll need this line. Okay, I'll can create it later on. Perpendicular. Okay, translate. Okay. Okay, let's keep it. Now we'll fix the position of trunnion. Okay, for that what I will do. Okay, again I'll the radius of this gate would be about so what is the height of the gate? 11.25 into 1.5, so it will be 16.875 will be the radius of the gate, and the crest location of the gate I'll identify. I'll drop a 20 degrees line from here, and let's see, it will be approximate. Mechanical guy will provide that. Okay, rotate this line 2 points by 20 degrees. 90 degrees. Okay, translate. Okay, actually it will, I mean, the location of the trunnion will be dependent on the nappe, water nappe. Anyways, for the timing, we'll keep it here. So it has to be provided by the hydraulic engineer. So I was getting 16.875 radius. So I'll draw a circle from here, 16.875. Apply, and a circle from here. From here. Okay, I'll keep my trunnion location somewhere here. Okay, so draw an arc. Center point is this one. first point and last point. Okay, then this will be the position of the Crunian. Okay, let's measure the distance. It should be 16.875. Okay, I don't need these extra curves. Okay. Mm. This is okay. So my pier ends here, and I'll extract a surface from here. Okay, this will be my spillway profile. Okay. Change my work plane to this plane. Okay. Create a surface here and divide this solid. So my pier will end here. Extracted this. Okay. Then I'll have gate groove. Say how much for 1.5 meter from here I'll keep. Okay, firstly I'll imprint this line also here. This is the line for called breast wall. Okay, say and breast wall thickness also I can do it right now. So thickness is say 3 meters. Translate this line. Three meters. Okay, and here suppose this is 0.4 meters at this location. Okay, and from here say that 30 degrees it will cut this line. So I have a line here. Sorry. Rotate last line. Minus 30. No, in other direction, plus 30. So, okay. Translate this. Okay. And then coincide these two lines. Okay, so this will be my breast wall profile. So I can imprint these lines here. This arc also I should imprint. Union I'll require. Okay, before that I'll create one, what you call, gate groove location also. So suppose translate this last line by 2 points, direction by 1.5 meters for gate groove. Okay, so this will be the gate groove. I should have copied it. Okay, and then imprint this also. This one and this one. Okay, now let's create a Trunnion beam, profile of Trunnion beam here first. So for that, what I'll do, change my work plane to this plane, create a rectangle, make face. From here, say length is 4.5 meter, comma, say 4 meter is the depth of the beam. So this is the beam. Translate this to this location. Okay, and let's extrude this. How much was the, okay, arbitrarily I'll exclude this time. Later on extrude it again, say 5 meters. Okay, let's keep 5 meter. Okay, and from here I'll cut it at about 75 degrees. Extract. Okay, rotate. Okay, we can divide this. Don't need this surface anymore, and we can translate this beam now to here, and we can imprint this. I don't need this. So I have Tronian beam location, this location. Okay. Now I can cut this one also. Change my work plane. Y direction. Okay. Oh, plane should be okay. Otherwise, extract this. Okay. Translate. Okay. Divide. The last phase. Delete this. So overflow profile will be something like this. Okay. Now we have to create the pier. Let's see what is the maximum water level, tail water level. 241. Okay. Okay. Come back here. What's this level? 234, I believe. It is 234. 7. Suppose I'll keep it at 241 is the maximum tail water level. No. Keep it at say 244. So 10 meter. I'll create one line 10 meter. I mean, all these levels will be given by the hydraulic engineer. So 10 meter, two dimensional, 10 comma 0. Okay. And here, let's say from here the width is okay, but 10 meters from the upstream face of breast wall. Side it's, let's say it is 10 meters. Okay. And what is the RL level here? RL is at 288. Okay. So this was 293. So 5 meters. 5-meter freeboard is there, no? So translate this towards this 5 meters. Okay. So I should imprint this. Okay. And let's say downstream slope of NOF section is say 0.65:1. So let's extract this one. Okay. And I'll rotate this 0.65:1. How much will be the angle then? Points degrees 10. 0.65 horizontal to 1 vertical. This much degrees, 56.97163. Rotate this like this. Okay, opposite. Okay, and translate this face here to here. Okay, okay. So we'll have this line. Okay, I'll create line here. That would be better. Create a 3D line here. To here. Okay, I don't need this slope. Okay, so I'll have a profile like this, and here it's like this. So I need some cover for this, what you call, for this Tronian beam also, some good distance, so that there should be sufficient distance here beyond this of the piers, so that stresses are within the permissible limit. So for the time being, I can keep something about 3 meters, 3 or 4 meters. Over this line, let's keep it this much distance at least. Translate this line. Okay, what is its elevation? This is 252.584. Okay, let it be 2, whatever it is. Okay. The line will also work. No, 3D. This one and this one. And can coincide these two lines. Okay. See, this profile, this pier profile, it is dependent on the Nepe profile. So I'm presuming that this Nepe would be lower than this, and MWL I have considered higher elevation at the downstream end, higher than the maximum tailwater level. Anyways, I'll keep this profile for the pier. Okay. So for pier, I'll imprint these curves now, this curve and this curve. Shorter distance, apply. Okay. We can have steps here also if you want, but let's keep it somewhat simpler. Okay, otherwise. Boolean, cut this one. Okay, so this will be the pier profile. Okay. Switch it off. So this will be the pier profile. Okay, and I will do this. I'll keep it as 3.5 meter. Now fillet this. Consider 3.5 meter thickness of the pier. Okay, create a 3D line here. Okay, so this is the profile of the uh, pier, and then the other side it was 15 point, sorry, the total width of that was 15.35. How much was the width of the eight, uh, gate? That was 8.35. Okay, okay, I had this profile for my what you call spillway concrete. Okay, and firstly I will mirror this. Okay, how much was the total distance? 460.5. Okay, extrude this in X direction, reverse 460.5. Okay, and translate this by 3.5 meters towards this side. Okay, don't need this surface anymore, and I don't need these lines also anymore. Just remove it. Okay, then each bay is 8.35. Extrude this one, this one. What else? Nothing. 8.35. Okay, mirror this. Translate it here. Okay, so this bay is ready. Okay, I can probably cut this pier with this, and then I can probably somewhere here I can have some 45-degree angle. That I'll do now. Boolean. Firstly, I'll cut this with this. Okay. Extract this surface. Okay. Rotate this. At an angle of 45 degrees. Okay. And move it somewhere here. Translate it slightly so that it crosses the pier. You can easily divide these. Divide. Okay. So I have this one bay with me. And if I want, I can boolean this bay. I'll boolean this bay only. Okay. So gate groove I've not modeled. Okay, anyways, model it now. Extrude this. Say it's 1 meter on each side. I mean depth of groove. Keep it say 9.35. Half a meter. No, okay, 10.35. Translate. Okay, boolean cut. Okay, so I have this gate groove also. Okay. Now I can mirror this, or I can move it also. Move, translate, copy 2 points. 15.35. Number of times 13 or 29 times. Okay, so our overflow block is ready. Okay, I'll model gallery also in later on. So first thing is I'll create a, to make it easier, I'll create a new geometry set. I'll rename it to overflow block. And include all these solids to here. Okay. Now we have this non-overflow block section that I'll be modeling concrete non-overflow block as well as the earthen dam section of non-overflow block, and then I'll be also modeling the excavation in coming webinars. So this for this session, this is it from my side. We'll meet in the next session.
So this was a great presentation, Chetan sir. I hope this must have given a great perspective of how to utilize Midas FENX for this detailed modeling. And in the upcoming sessions, like we have mentioned in the agenda as well, we'll be doing the complete modeling of data structure. So because of time shortage, we won't be able to take questions today, but definitely tomorrow we'll start ahead by taking up a couple of questions from our users, and then we'll proceed ahead with our next session. So thank you so much everyone for being here with us in this presentation, and I hope we'll utilize the most of it in the upcoming webinars as well. Thank you so much everyone. And yes, in case if you still have any further questions, please you can always email it to us on rishabh@midasIT.com, and we'll be glad to assist you in your questions. Thank you so much everyone. Thank you so much Chetan sir for your time.